the main session.
Hello, everyone. Good afternoon and good evening, ladies and gentlemen. A very warm welcome to all of you. Thanks to joining the IEEE Region 10 webinar series R10 Talk. I am Emi Yano, Region 10 AA Committee Chair. It is my great honor to be the host of our sixth webinar on game theory, introduction and its possible application by Professor Sardar and Islam. IEEE R10 Talk is a joint endeavor of IEEE Region 10 committees, Industry Committee, Professional Industry Relationship Committee, Professional Activity Committee, Young Professional Committee, Women in Engineering Committee, and Student Activity Committees. We were focusing on enhancing the awareness on trending topics to the community. Before we introduce our speaker, I'd like to announce some ground rules. All our attendees are muted on the entries. You are not allowed to unmute, but you are most welcome to introduce yourself on the chat box. If you have any questions and comments, please use the chat box or Q&A box. We will have a special Q&A session after the talk, so we will try our best to answer all your questions today. And please make sure this webinar is recorded and streamed live via IEEE Region 10 Facebook page. Okay, I'd like to now move on our welcome address. To deliver the welcome address and introduce our speaker, we have a special guest today, Dr. Presi Bajaj. She is the Vice Chancellor of Calcutta University, Noida, NCR, India, and she is currently serving IEEE Region 10 Education Activities Committee Chair. Thank you, Dr. Presi, for joining us today. Over to you.
Thank you so much, Emi. So IEEE Region 10 Senior Leadership Team. So we have Mr. Sanjay Kar, Industry Relations Committee Chair, Vice Chair, Technical Activities, Mr. Jia, Professional Activity Chair, Prakash Lohana Saab, and the Exicom members, student members, and the online community. Very good evening to one and all. Welcome to IEEE Region 10 webinar series, IEEE Region 10 Talk on Game Theory, Introduction and its Possible Applications by Professor Sardar M.N. Islam, Professor ISILC and Director of Decision Sciences and Modeling Programs, Victoria University, Australia. As you know, IEEE Region 10 Talk is a joint endeavor of IEEE Region 10 Industry Relations Committee, Region 10 Professional Activities Committee, Region 10 Young Professional Committee, Region 10 WIE Committee, and Region 10 Students Activities Committee, focusing on enhancing the awareness of trending topics of the community. And game theory is going to dominate in next 20-30 years. So that is a very good topic selection by the team. Game theory basically is a theoretical framework for conceiving the social situations and amongst the competing players. The game theory is can be applied in different ambient of artificial intelligence. and that can be used to describe many situations in daily life and the machine learning models. The medicine, biology, environmental, agricultural, political science, law, ethics, insurance, war, defense, business, finance, telecommunication, transport, computer systems, sociology, psychology, hazard, and many, many. With this, I would like to introduce the expert. Today, we are going to have a very interesting session on game theory by the expert like Professor Sardar. As Professor Sardar, Islam has lived, studied, and working in different countries and visited different regions of the world. Holistic approach for his research and academic work, and he has undertaken rigorous scientific studies of emerging issues of different disciplines of artificial intelligence, business analytics, digitization, management science, machine learning, corporate governance, game theory, finance, economics, accounting, business, industrial engineering, and law. His academic work has gained international acclaim in the above areas, resulting in many honors and awards, visiting at an urgent professional appointments in different countries, appointment in editorial roles of journals, and keynote speeches at international conferences in several countries. He has published 29 scholarly academic books in different disciplines, and each of these books have make significant scientific contribution to the literature. These books are published by prestigious publishers, and the majority of the books are published in highly regarded book series. He has also published 250 research articles, including some top leading international journal articles in his specialized research areas. With this, on behalf of Region 10, let's welcome Professor Sardar M.N. Islam for today's talk on game theory, introduction, and its possible applications. Welcome, sir. And over to you, Inu.
Thank you, Tracy. Prof. Sardar. So please share your slide, and now stage is all yours. Prof. Okay. Now we can see your slide, and you are still on mute.
Prashant, can you unmute him?
Me?
Okay, now we can hear you.
Okay, that's good. Okay, so that's the topic. This is IEEE group. So in application, I will be actually focusing on more engineering and computer science areas. Though, as you heard, the game theory can be applied to all areas of life. But most of my discussion of application will be related to engineering and computer science. I will proceed very slowly because it's a technical topic and something about me. As I said, my mission in life to really develop better people, better technologies, and so on. So let us collaborate for this. That is my mission. And my structure of this talk, first I will focus on three parts of my talk. The first part is analyzing game theory. And in that section, I will discuss some game theory basics. What are the different forms of game theory models and elements of game theory, different dimensions of game theory, some well-known games and basic solution methods, algorithm, and and the areas of application in operations, practices, and research. The second part, I will discuss games. First part is analyzing the game, and in real life, we actually try to develop games and game theory models. So how to develop game theory models, game theory systems, game theory operations, game theory machines. So second part, I will discuss that. So I will go discuss the how to develop this games, designing games for systems, for operations, for activities, for organization, how to develop those models, how to solve this model, and the areas of applications. What are the mathematical methods, computer program? I will also discuss in second part. And the last part, there are different miscellaneous that so discuss, like how to do empirical research in game theory, and what are the different issues in designing games, and there are issues related to game theory and moral philosophy. And my last word, the can game theory save the world and humanity? And I am optimistic, and I am an advocate of the view that game theory plays an important role, and it can really save the world and the humanity. And I'll make some conclusion and then give references. We start with the game theory basics, but those who follow the developments in scientific area, scientific paradigm, theories, mathematical modeling, and so on, you probably have seen that in many years now, many people are getting almost every year Nobel Prizes in game theory. So this is an evidence that game theory is very important. Some people think, including me, that game theory is probably the most important scientific paradigm, and some of us, many people also think that the game theory applications in different areas in the world can save the world and humanity. And I will just, at the conclusion, I will mention why we think that way. Some people are very obsessed or addicted, you can say, to game theory. And there are people, they think that the game theory is a cult, it's not a paradigm, it's a sort of way of life, it's a philosophy. And as I said, it's just not like a belief that this is the way we should analyze the world and solve the world problem and develop systems. So that is the introduction that we, all of us, many people may not agree that game theory is so important, but certainly we have to agree that game theory is a very important paradigm or a framework or a mathematical model. This is evident from the fact that in recent years, most of the years, people are getting Nobel Prize for their work in the area of game theory. So that certainly is an evidence that game theory is very important. And as I said, if you do Google search, you'll see that game theory can be and has been applied to all areas of human existence and activities, including science, engineering, to family law, and so on. So that also shows that game theory is a very important paradigm or framework or modeling or a conceptual framework to deal or design or solve many global problems. So first we start with the simple concept. What is when we are talking game theory, so what is a game? So we know that in everyday life, we are all playing game. In the family, there are games between family members. In the office, organization, there are games. People play a sport. So a game is a scheme, a strategy, a diplomacy or action or plan or a trick. So that is game, just a strategy or a diplomacy, taking a position. And in formal game theory, game theory was developed by mathematicians von Neumann and Morgenstern at Princeton University, and this is an area of applied mathematics. So game theory models are developed in mathematical form. So game theory can be defined as a mathematical study or model of strategic interdependent interactions among a multi-agent system for optimal decision making or strategy formulation. So what it means in game theory, we develop a mathematical model of the strategic interactions among different players in a multi-agent system. Many of the engineering and computer science systems are multi-agent systems. For analyzing the system and solving the problem so that a decision can be made or action can be undertaken or an equilibrium position can be achieved or a solution can be achieved also. So game theory is a mathematical model representing strategic interaction among different agents in a system for understanding the strategic relationship, but also finding some solutions or finding some decisions or strategies. And those in engineering and computer science, there are many applications of computer science modeling and so on. And I will give some references where, if people are interested in engineering, they can see that those books and then see how extensively game theory has been applied in engineering systems and operations or engineering research. And in addition, as I said, game theory can be applied in many other areas, including politics or business and biology and so on. There are many different forms of game theory models. The most popular or most widely known game theory models are cooperative or non-cooperative. This is how we distinguish between in the most common form because when we are in a multi-agent system, where there are different multi-agent system, or we can also call distributed system, where those systems are not governed through a central system, but are coordinated through a central system, but they are distributed on different areas or different parts. So in that sort of multi-agent system, the agents or the players can cooperate among themselves. So if they cooperate, then we can say this is a cooperative game. And if they don't cooperate, then we can say this is a non-cooperative game. And more technical point, the game theory can be normal form of game or it can be extensive form of game. In normal form of game, it's not probabilistic. It's just decision is made at one time. In extensive form, the decisions are made at several stages. It can be two-person game. Then if there are two agents, two people, or two players involved, then we said two person game. that can be n-person game. If any number of n, it can be even millions or billions people can be involved in a game. And the game models can be stochastic models when the values of the parameters in the mathematical model or the strategies are not known. Then we say that is the stochastic game theory model. The game theory model can be for a particular period, but at the same time, many of the game theory models are dynamic. So over a period of time. And game theory can be also evolutionary game theory. Evolutionary game theory means, when one person is taking some actions, the one period, next period, the game rules, game framework, game model is being changed, and the next period or next stage, another person is taking another action, but the parameter values may change. So solution will be in that case will be different. In game theory, in traditional game theory, is based on the assumption that the players are rational. That means they take action or make decision which is right, correct, or rational. But the question, what is rational, what is correct, those are controversial. In simple form, it means that the agent will take interest that will be the best for his benefit, or for his interest, or for achieving his goal. So it's a rationality, and sometimes it's also called self-interested motivation. But that is the traditional game theory. But game theory models have changed. There are new developments, and in one of the new forms of game theory is called behavioral game theory. In behavioral game theory, we don't assume that people only take actions or decisions for their own benefit or interest. We consider what is called the bounded rationality. Bounded rationality means sometimes people are not rational. They cannot consider all the phenomena and cannot make a right or correct decision. The decisions can be emotional, decision can be faulty. So those psychological aspects, like a question of emotion, stress, irrationality, those we can also consider when the some of the players may not be rational, may not act for their own benefit, but they may act for the benefit of other people. So those sort of psychological, social issues can be also included in game theory model, and then it can be a mathematical game theory model based on the behavioral or psychological concepts and issues to represent the views that people may not be always self-interested. People can be people can also be altruistic. They can consider other people's interest more than their own. So those issues can be included in game theory model, and this area of game theory model is called behavioral game theory model. So the foundation, basic background of game theory is the multi-agent system or distributed system, and many of the engineer and computer science people, they are certainly familiar with this terms. What is a multi-agent system and distributed system? Like transport system, like power distribution system or transmission system, and even in industrial engineering, many of the industrial systems are distributed and involve different agents, different machines, different parts. So when different parts, different agents, different operations are involved, then we call it multi-agent system or distributed system. So the elements of game theory that we are trying to develop a mathematical model of multi-agent system or distributed system where there are different agents, different operations, different people, and their actions, their operations, or their strategies, or their decisions are interdependent. That means person one's decision is dependent on persons two's decisions and actions, and so on. So, so there are different agents. There should be different agents, and their activities are interdependent. And there are some rules of games that will govern these interactions. Like in our current, we are playing game. For example, I am giving a webinar, and there are participants, and there are organizers. So there are, at least 3 type of agents here. So what are the rules here? The rule is that the organizers will introduce the speaker, and then the speaker will give the presentation, and then the participants, audience, will initially hear this presentation, and at the end they can ask some questions, and then the game or the webinar will be concluded. So these are the rules of the current game. We can call it, we are in a webinar or a seminar game. So, and in this game, all of us, like we have to follow the rule of the games that I have just stated. Like I am presenting, I'm the presenter, so I'm discussing the topic. So organizers are not presenting the material. So the rule is that the speaker, presenter will discuss the material. So I am following the rule. So there will be some rules of games. And when the games is done or played or performed, or in the process of the game, there will be some payoffs. Payoffs mean outcomes. With the outcome, there will be some outcome. So what will be the outcome of our present game? I will give the presentation. People will probably people will probably know or learn or understand what is game theory, or they will hear, and that may give some benefit to the attendants. It may be some benefits to participants. It may be benefits to speaker, to me, that I have presented a seminar, and it will be some benefit to the organizers, that they have organized an activity for IEEE 10 region. So these are the values. There's increasing values, the values of outcome in numbers. So for all parties. And then these are interactive, what the speaker, presenter is doing, and the organizers and also the participants, all we are, here, we are interconnected through our actions and our strategies. And in mathematical model of game theories, we try to find some algorithm and computer program. We solve these models, and we get some outcomes. Outcome will give the final results. The game theory is why it is very important. Why it is very important? Because in the world, especially in many areas of engineering and computer science, these multi-agent systems have different problems. So what are their sort of problems? Normally, the information of that different people have may not be known to each other. For example, I don't know how many participants currently, for example, in this seminar game, and what are their level of knowledge and education and understanding of game theory, what are their interest. And though the participants organizer know some about me, but they don't know maybe many other things. So there are, I don't know about the organizers. So there is information asymmetry, information problem, and then incentives. For example, why, because the best multi-agent system will be achieved uh, when the agents or the persons or different elements or different units of multi-agent system, they cooperate, they coordinate, they collaborate. But the question is why they should collaborate. What is the incentive they should collaborate? Because in many real life situations, there are conflicts of interest. Different people, different groups, different countries, different family members, they have different interests. So there are conflict of interest. And in business or even in engineering, some areas, we also see what is called agency problems. That means, principal agent problem, there are in a system, one can be principal, one can be the agent. The agent is supposed to work for the benefit of the principal, but in real life there may be agency problems. That means the agent may not work for the best interest of the principal. And as I also mentioned, asymmetry problem, the institutions and culture of different people, different agents may be different. In different cultures, things are done differently. So this sort of principal agent relationships are very dominating in societies, in economies, in the world. Also, different countries have different interests. So these sort of problems actually motivated the development of game theory in the present form. And the purpose of game theory is to design some game model or game mechanism or game principles or strategies. These game models or mechanism that can solve these problems of multi-agent system, leading to a better system or cooperative game models. And originally these areas were developed by Harvey, Stiglitz, and so on. These are the Nobel Prize winners for their work in these areas of game theory. Game theory has different dimensions, because game theory is a mathematics subject. It's a unit. It's a mathematics discipline. So certainly it's a very advanced form of mathematics in game theory. But the intuition of game theory is very simple. What we have discussed so far is very simple. And it can be, this game theory intuition exists everywhere in the world. It has a theoretical aspects. Game theory, very high power theoretical aspect, but it has very real life practical application in almost all areas of human activities, including including very important applications in engineering and computer science. People do academic work in that area for teaching, research, and the game theory is used in operations of, say, transport system, power distribution systems, and in systems engineering, and even in professional practices, in laws. Particularly, the game theory is used extensively. Laws or even business management and so on. And there are two dimensions. One is the analyzing the games, and the second is designing games. Because in analyzing games, we try to understand the game environment, in the underlying relationship and underlying interest, underlying strategies. But in another area of game, we try to design games. That means we try to different design operations. We try to different system that will be the efficient system. Like we try to develop a power distribution system will be efficient in terms of avoiding uh, disturbances, having stability and so on. And in companies, for example, we try to develop an organization where the organization will be efficient and we try to achieve its best performance. So designing games is also important, and I will discuss it later, but it is also called mechanism design. There are many form of popular games like Prisoner's Dilemma. I will discuss this game. Zero-sum game. Often we heard this phrase saying that, oh, we are in a zero-sum game, or it is not a zero-sum game. And sometime we also hear the word non-zero-sum game. And there are also some very popular name called chicken game and so on. And all these games can be also take cooperative, non-cooperative, or stochastic, dynamic, and so on. So I just give a very simple example of a game theory model with a two-person. It's a two-person game because my understanding, just my talk should be more elementary level. So I'm not going to go to more mathematics area. I will be focusing more on intuition side to see how this can be applied in engineering and computer science. So example is here. This is a game model. This is not represented by mathematical equation. This is represented in a matrix form. And this is quite common to represent this sort of simple two-person games in a matrix form to make it more visible, to show the intuition of this game. So this is we are showing this is the game situation. We are representing by a payoff matrix. These are the payoffs. 10, 15. These are the numbers will be the benefit or outcome for these two players. There are two players, a player A and player B, and player A can take three strategies, 1, 2, 3, and player B can take strategy 1 and 2. And then by taking these strategies, these will be the outcomes, the payoff for each action. So if player A takes action 1, and if player B takes action 1, then, for example, the outcome, for example, the profit, two companies, they are doing some joint production, and if company A does some strategy and company B takes some strategy, the profit will be 10, for example. And then if the company A takes strategy 1 and B takes strategy 2, then the profit or outcome will be 16, for example. So we represent different strategies or actions or decisions and their outcome here. And then you can see that this, and then this is the game situation. We are analyzing the game here. So from this game, we can see these are the possible strategies. We have represented the game, two-person zero-sum game. This is a zero-sum game, means it's what is one person gain that will be lost to the other person. So in this case, if we have a two-person zero-sum game, then these are the outcomes, and then we try to see if that is the case, then what decision A will take and what decision agent B will take. And this to find the solution, or we can also call equilibrium, or to solve this problem, decision problem, to find the equilibrium decision, we need to find an algorithm, and we call solution method. And in then this is we are solving by hand, by intuition, but most of the complicated mathematical model we have to find more detailed algorithm and then computer program to find this solution, or find the optimal decision or optimal outcome. So in this case, the algorithm is called mini max, or it is also called sometimes max min. That means we try to find out what is maximum for one and what is the minimum for other one. So if we can see for this row, when player A takes a strategy, then there are two outcomes. One is 10 and another one is 16. So from these two numbers, the minimum of this row is 10. Similarly, we found the minimum for other rows, and we find the maximum from the column, like this column and that column. So we can see when A takes action 1, B takes action 1, and the outcome is 10, and that is maximum for this column. And then we can see for this column, the maximum is 17. So what we are trying to see, these are the minimum for 10, and these are the maximum minimum for A, and these are the maximum for B. So we have to find, because this is a max min solution, so we have to find a solution which is maximum for one and minimum for another person. So if we compare this row, this result and this result, so what is common? We can see that 10 is common. So minimum row is 10 and maximum column is 10. So the 10 is the solution to this problem, or equilibrium decision. So what it means that company A will produce, for example, 10 units, and company B will also produce 10 units, and that will give a mini-max solution. So it will be, say, a maximum benefit for B, and that will be the minimum loss for A. So that is called mini-max solution, or zero-sum game. So we found a solution. So we found the optimal outcome, or we found the optimal decision. So that is an example how game theory model can be applied to real life decision making or strategy formulation or analyzing game. And one interesting game that I will also discuss is called Prisoner's Dilemma game. This is very famous, and if we think, when I'm presenting, even you can think that this sort of situation exists unfortunately in real life, and that is the reason for many of the world global, family, societal, national problems. What is called this prisoner's dilemma. This is the foundation of many problems of conflict and war, and other problems in the family, in the organization, in the associations, in country, or even in the global level. So what is this prisoner's dilemma? It's a very famous form of game. I'm just explaining it. For example, this is a hypothetical example. There are two prisoners, and these two prisoners are caught by police, and then the prisoners need to make decision. Have they done a crime, or violated the law or not. So the two prisoners, the police have caught two prisoners, and now the prisoners have to make a decision. That the two prisoners will have to make separate decision. And these two prisoners are, police put them in two different places. They are not sitting together, and they don't know what the other prisoners is going to decide. So this is a game theory problem between two prisoners and the police. So the issue is the prisoners have committed a crime or violated a law, and then the police are asking what they will do. And the issue, but the game problem is that will these two prisoners will confess that they have done a crime, or one will confess, other will not confess, or both will deny. So this is a game theory problem, and the rule of the game, police is telling to these two prisoners that if both of you confess, then each of you, if both of them say, because police is interrogating them separately, so they don't know what the one prisoner will say and what is the other prisoner will say. But police are telling them that if the two of you, these prisoners, if you confess that we have done it, then both of you will get a 10-year sentence. And if one of you confess and the other one does not, then the first one will get free because he confessed, but then the second one will get 15 years sentence. And if both denies, then both will get only 2 years sentence. So I'm asking, because I cannot hear your answer, but I'm asking you the question to think. Hypothetically, if we are in a situation like this, hypothetical, then what will you do, or what will you do? Should we confess, or should we both of us confess, or don't confess, or both deny? So this is called prisoner's dilemma. What is this showing here in this hypothetical game? I just referred to we and you, but these are just a hypothetical reference, nothing to mention to you or me. But it's a hypothetical. In this hypothetical situation, what is evident is this game shows the conflict of interest and reasons for selfish behavior. Because people can be selfish because different people's interests are different. In this case, the first prisoner can confess, then he will get a free, no prison, but the other person will get 15 years prison. And but if both of them confess, still they are getting 2 years sentence. But in that case, one person may be selfish and may be self-interested. Then they will think, first I will just confess, so I get free, and the other person will get 15 years imprisonment. So in this hypothetical case, you can see that there exists conflict of interest. And this sort of situation exists, as I said, can exist in family, in society, in country, even in the world. People, different agents have different people, have different interests. So this shows the dilemma. And that is the basis of game theoretic analysis and modeling. How to solve this prisoner's dilemma so that people will cooperate and collaborate, and they will give good outcome for the correct outcome for the society and correct outcome for them also. And this sort of situation are also common in computer science and engineering. There are different basic solution methods and algorithm. We have discussed max-min, but there are more famous, well-known algorithm and solution methods, Nash equilibrium, dominant strategies, joint optimization methods, many other algorithms. And So when we choose an algorithm, we need to choose a computer program. And if we put the mathematical model into the computer program, and computer program will find the solution and will give us the optimal decision or optimal outcome or optimal mechanisms. And some of the useful computer programs are given here. Even nowadays, Python and Java are also increasingly used game theoretic modeling, but in the traditional MATLAB and Mathematica are the traditional ones used for game theory modeling. And like game theory in engineering and computer science can be applied in many areas, because there are hundreds and hundreds of areas. I cannot go through them, but in different areas of systems, system engineering, system development, in networks, in organizations, and all these organization systems and networks and operations. The purpose of designing game is to increase efficiency, so the system will be efficient, to have a fairness among participants, agents, or parts or networks, and there is incentive for cooperation, collaboration, cooperation, and have information symmetry and coordination and so on. And the strategies normally that can be followed, we can do this sort of developing collaborative or coordinating model through negotiations, through developing cooperation, or conflict resolution, through altruism, reciprocity, and so on. So as I said, when you want to design games, this area of game theory we call mechanism design or designing games. So we design some strategies or define some incentives or some rules. So the simple definition is in mechanism design is a mechanism is a set of actions for achieving some outcomes or developing some incentives. So in mechanism design models or designing game models, we try to find what are the mechanisms or incentives or institutions or strategies we can follow, so people will cooperate, people will collaborate, and will achieve optimal outcome. So we actually develop a mathematical model and find the algorithm and use the computer program, or solve the analytical. We find what will be the strategies that will give maximum outcome, or what are the institutions or operations or system that will give optimal outcome. Like for in power system development, we can find out the distribution system that will be optimal for the company. So we can develop a game theory model, solve it, and find out what sort of distribution system that will resolve this sort of information asymmetry and conflict problems, and give the optimal or efficient or fair power distribution system. And these incentive systems can be by giving ownership, remuneration, non-economic systems like culture, laws, regulation, and so on. Those are also part of mechanism design. So this sort of strategy formulation are very common in engineering, all engineering sciences, including computer science. The areas of application, the functional areas, we try to develop efficient multi-agent systems, designing, in engineering and computer science. We trying to develop a mechanism in institutions, policies, or incentive. We develop better organization, also risk management. We develop strategies for minimizing risk, or strategy formulation, conflict resolution strategies for cooperation and to minimize competition, and also in law, with this game theory is used for litigation, settlement, and moves, and so on. And industrial engineering, supply chain, production planning, in these areas, there are many applications of game theory, and especially also many of the interesting and useful computer science areas. Game theory is used very extensively, and of course, even informally, officially, many of the areas of war, diplomacy, international organization, negotiation, even politics and voting, and on law formulation, formally and officially, many of these areas, game theory is used and has been used also for many years. So, as I said, mechanism in design is designing a game. Is like in this game theory models or designing models are used. Some people certainly have seen is their discipline in the area of joint optimization model, designing efficient networks, machine efficient transport systems, water management, power production, transmission and distribution, smart city, algorithmic designing algorithm, and platform machine learning, all those areas. This the mechanism design models have been designed, mechanism design models have been developed, or games have been designed. Game theory models have been designed in those areas. And most common and very popular game theory model in engineering, computer science is called joint optimization model. It's an algorithm which is very simple, is developed as a sort of a mathematical programming model where the interest of all the people are included in the objective function, and all their realities or their systems are represented by the constraint. So it can be solved as an optimization problem. And so in this case, large scale models for designing games or mechanism models can be developed for engineering applications. So, as I said, I will go very quickly, but as I said, the purpose of designing mechanism design is to develop efficient mechanisms, efficient organization, efficient systems, efficient machines, efficient corporations. And in this sort of optimization model, joint optimization models for mechanism design, there will be an objective function, welfare function, which is the joint objective function, and subject to some constraints, the constraints of the system, but there will be also incentive compatible or individual rationality constraints. These constraints are the mechanism design modeling constraint. This constraint means that we have given some conditions so that all the agents will have incentive to cooperate, and they will have some incentive to remain in the game and cooperate and try to achieve the optimal outcome for the system, and that will also give them optimal outcome for individual each agent there. So mathematically, a simple sort of analytical model can be represented like this. This is a sort of joint optimization model, and if we develop, for example, something like that, and then if we solve analytically, or if we solve by if the problem is big, if we develop an algorithm and solve by Python, then we can achieve a mechanism or some mechanism that will give us optimal outcome or optimal system or optimal operation that we are considering. So mechanism design is a game theory problem. It's sometimes called also adverse game theory. So it's because it's as I said, in the original game theory, we analyze the game. In mechanism design, we just develop a game. So it's the opposite of the traditional game theory modeling. As I said, real life, many applications. If we search, we'll find out. Normally, in large scale engineering application, we have to do a computational model. So we have to collect data, develop the model, and the model will be computed by some computer program. Then we try to find their implication, and then we try to find out the optimal strategies, or we try to find out the optimal mechanisms or systems or incentive and so on. But the problem is that if this mechanism design and game theory models are very non-linear, and if the game model is big, then there are problems of computation and complexity, and many of the problem may become NP-hard problem. And so we are going to the conclusion that because many of the engineering system or real life systems or environment are multi-agent, and there exist agency or conflicted relationship. Therefore, game theory is relevant for analyzing those relationships. And the game theory models are very useful to analyze the game situation, and also useful for developing the perfect or efficient system for real life companies, organizations, or machines, or power systems, and so on. And then this can be used also in professional practices, operations of different engineering systems, research and develop we develop the model and analyze, and then we develop the mechanism design issues and apply the model and find the best outcome, best system, or best operation, or best model. And as I said, the traditional game theory model have been or being now more extended to behavioral game theory area, where people, emotion, mind, psychology, culture, institutions, those can be more formally included in the mathematical model, and their implications for cooperation, non-cooperation decisions making can be analyzed. And there are a lot of different ethical issues, moral issues in game theory, like should the agent will act for their self-interest or not, or should people be altruistic, think for other people's interest. Many of the, should we develop cooperative culture through cultural engineering? Should society adopt the culture of cooperation? And there are some areas, especially those who are familiar with those who are familiar with the artificial intelligence issues in computer science, then they will also know that the artificial intelligence is the most serious issue humans have faced so far. And artificial intelligence is my another area of interest and expertise. And those who are familiar with artificial intelligence issues, we will certainly agree that there are many benefits of artificial intelligence, but there are enormous risks also. Many great scientists, great thinkers are also worried about the future of human being and future of the world and the existence of a human civilization, even physical world and so on, because of the emergence of artificial system intelligence. And one thing is that the game theory can be actually used uh, very efficiently, very extensively for analyzing artificial intelligence issues and developing game theory model that can possibly solve many of the problems that we envisage because of the emergence of artificial intelligence. So for that reason, and many of the conflict in the current world, even wars, can be and also have been analyzed and have been tried to solve this conflict and wars by using game theory. So game theory really can play an important role in the world. That's why even I think even saving the world or humanity. And many people, and especially me, I also think game theory can be the panacea of many of the current world problem, including problems of war, conflict, and especially also the problems that we are facing in computer science areas because of the emergence of artificial intelligence. Many of them can be resolved or fixed through use of game theory modeling. Some references, especially the first book, Game Theory with Engineering Applications, is the most relevant book for engineers, and the other books, Game Theory and Mechanism Design, and the third book, these are the books also very useful for computer science professionals. Thank you for your attention. And as I said, if beyond the seminar today, if you have any questions or if you want to collaborate in this area, or if you have comments, please send it to my email address given here. Thank you.
Thank you very much, Prof. We have many questions today, so let's move on to Q&A session. So first question is, what will be the hardware limitation you will see in implementing the game theory for real-world applications?
So sorry, the first part, what is the real life?
What will be the hardware limitations you will see in implementing the game theory for real-world application?
Hardware
Application.
Okay,
hardware
yeah.
Limitation.
Yeah, that's right. Is as you know, we can have a NP problem, NP hard problem. But if we have better hardware, that is also very good. That we can find many sort of really large scale game theory model for practical applications. So good hardware, better computers is necessary for developing real large-scale game theory models. If we can use the quantum computing, quantum technology, that will be even better.
Thank you. So next one is how game theoretic approaches contribute in maintaining the machine or engineering systems?
The engineering maintenance can be also based on game theory because different maintenance problems are interrelated. Because one part of the machine can be related to the other part. So maintenance problem in one area related to the maintenance of other area. So in industrial engineering, maintenance problems, game theory is used with artificial intelligence. So one unit of a maintenance system has intelligence to understand the maintenance problem in other areas of the maintenance system. So then they can interact and find out what will be the best strategy or best time or best form of maintenance that is necessary or to be done. So that's the application of game theory in maintenance, but based on artificial intelligence.
Thank you. So the next one is, what are your thoughts on the game theory application significance and the future trend in the healthcare domain?
In the healthcare?
The healthcare, yes.
Many of the healthcare systems are based on game theory. Because in even healthcare system, different agents or different participants' interests are different. The interest, because I have a doctorate students currently. He's writing his doctoral thesis in the area of using game theory for designing efficient hospitals. The hospitals, the part of healthcare. In the hospitals, the interest of different parties are different. So, for example, if it is a private hospital, the owners will have interest to make a maximum profit. The doctors may have interest to finish the job quickly and go home. The patient interest are to get the best health outcome. So how do we develop a efficient hospital? So one of my students, he is writing a thesis using quite advanced game theory modeling, how to develop an efficient hospital system. So this is an example how game theory can be applied in the healthcare system.
Thank you. There are many issues in the hospital.
Yes, okay. And game theory is the best solution.
Mm-hmm. Okay, thank you. So the next one is there are many questions today. So I appreciate if you could share some resource to learn how to write game theory code. So there are some questions from participants. They want to know about more game theory. So if you have any resource or for example there any book name. So someone asked, can I ask the name of the book again? And it better GitHub you recommend to read code there, especially in MATLAB.
This because the game theory is so popular. If anybody searches, the MATLAB code for game theory, they will find. That's for sure, because I know them. So any book, any issue to find, literature, how to do coding, even how to, even I saw last time that there is a book on how to do coding, Python coding for game theory. So all the materials, everything is available on the YouTube and also on the internet. Everything is available, and there are short courses or even degree program, non-degree programs. So plenty. Just searching by game theory materials, people will find everything.
Thank you. So, and then next one will be the last question. So, any example using game theory in automatic control system design, such as cyber physical systems, or what are the players in such system design?
Sorry, cyber system?
Cyber physical system.
Many of the automated systems are based on game theory. For example, I give a more popular so many participants will understand. For example, robots. There are many in engineering operations. The different robots cooperate among. They participate in performing on task. Somebody, like in coronavirus time, Some robots they have cleaned. Some robots they have distributed food. Some robots have probably done vigilation. So interaction among these robots, how that is done, that can be done through game theory based machine learning algorithms implemented in those robots. So the system are automatically reacting, different units are reacting automatically based on artificial intelligence and game theory. So the game theory helps to automate all multi-agent systems. So many of the systems, even in hospitals, in transport system, in smart city, they are based on game theory and smart contract, and they are based on the game theoretic principles and artificial intelligence integrated together and made the automated system.
Thank you very much. So thank you so much for the talk, and thanks a lot for audience for your very active participation. So thank you very much again. So I'd like to request all participants to give us your feedback on this program for improving our upcoming event. So by scanning this QR code or URL link, we will share on the chat box. Okay, so now we are moving to on the closing remarks. So as a closing remarks, I'd like to invite Prof. Prakash, IEEE Region 10 Professional Activity Committee Chair, and he is also a assistant professor and the head of CS department at Yasman Institute of Technology, Karachi, Pakistan. Prof. Prakash, over to you.
Thank you. Thank you, Ms. Amy Yano. It's really a nice, Professor Sardar Islam, your presentation, and it's really nice to listen and to understand this game theory topic. Though it's kind of an AIE, but I would, and then I saw the questions. The people are taking interest. Being an academicians, my thoughts are coming because that game theory is not restricted to computer science or artificial intelligence now, because this is the technologies or platform that can be used, as mentioned, in the health and engineering, in computer science, in economics, in social science, and in every aspect of the area. If you see, as you described. My thoughts are coming because being an academician, I'm thinking now our engineering graduates must also go through, at least have this basic understanding of the AI based courses, and specifically so they can use to form it, to design their models based on the game theory. Say, for example, if I'm going to give the example of because I'm also an electrical engineer, so see the distribution in the distribution sector, we may often face the problem of the power factors and the electrical safety and earthing. So using that game theory, at least we can in a position to model our and to know that how much power I'm going to lose, or how much I'm going to control this to improve my power factor. And if I look at the other extreme other areas of the engineering, like economics, so it's again this can be used and to model and see the economic values and of any business or any countries. And also based on the game theory, if you look at the risk management process, as you already mentioned in your presentation, it's really fine, because those areas they can use the game theory and to calculate their risk and see what they, at least their position is to take the calculated risk based on their model of the game theory. And also, if I'm looking at the areas, it's a game. When we are saying it's a game, So it means look at the games of hockey, football, cricket. So those players, when they are are trying to participate in international events, they can use, because it's all these strategies. It's all the models they prepare, the strategies, how someone go and to play in the grounds, and obviously every team try to win. So the games not can be win by whatever you should also be very to formulate your strategies to win those games. So it means it's really nicely, and also we need our students to at least encourage them in every area, to at least have some basic understanding. And obviously the AI is there, and those who have the expert domain can help and to formulate those strategies and learn the game theory. So, Professor, I really enjoyed that, and I thank you very much. The nice questions. And for me, because I'm also an engineer, also in computer science, and looking at that, and looking at nowadays, the machine learning and robotics, and seeing the Internet of Things. But that game theory helps in every aspect of our these, daily life aspect. So it's really nice, and I'm sure our audience and participants have enjoyed this talk. At least I did, and a lot of questions are there they've asked, and I also request the others, if any detailed question, as Professor has already shared with his email, you may contact. And I also thank you, Region 10 10 Talk team, Professor Dr. Zia and Emiano, and our YP chairperson Savitya, and all the team members who are working. So thank you very much for this tremendous efforts in bringing and knowing our participants about these new area. Thank you very much, sir.
Thank you a
Thank
lot,
you.
Prakash. Thank you. So again, so we would like to hear from you feedback as well. So please let us know your feedback via QR code or your link on the chat box. And please do connect with us through our LinkedIn, Facebook, and YouTube channel to know updates of IEEE Region 10 events. Next slide, please. And the next one, please. And the upcoming event, next event webinar on 21st August from 11 a.m. to 12:30 p.m. India Standard Time. We are having a seminar of personal branding to double your value by Nirshan. So please join us the next webinar too. And once again, thank you so much for joining today. And looking forward to having you all at the next event. Thank you, and have a good weekend. Bye-bye.
Can we have a group photo, Miss Emiano?
Yes, sure. So we would like to move on very quick group photo with panelists. So I would like to request all panelists to turn on your camera.
On account of this, I request all the professors to come to you.
Dr. Zia, can you?
Prakashji, where is your backdrop? R10 Talk backdrop?
Yeah, it's there. Just let me change it. Let me change it. Just
okay.
Just,
we will send it next to Takao-san, and the speakers also. I think it would be better. So it looks nice. Next time I will arrange for it. Okay, sir.
Yeah. Okay. Now it's fine.
Okay, Cypress Sound, can you take a photo?
Yes, I'm taking Dr. Zia.
Dr. Zia.
So, count of 3, 2, 1. Thank you.
Thank you. Okay, thank you very much. Thank you again.
Thank
Thank
you.
you very much, Prof. Sardar.
Thank you. Amy,
Thank
thank
you.
you. Amy, thank you. Bye.
Thank you.
Thank you
Bye
very
bye.
much.
Thank you very
Bye-bye.
much.
Bye-bye.
Thank you very much. Thank you very much.
Have a great
Preeti ji,
weekend.
namaskar and
Thank you. Thank you. Sanjay,
Did
going
you
very
enjoy it?
great.
Did you enjoy it?
Yes, and going
Yeah.
great. Very
Keep
excellent
listening.
seminar series. I was motivated. I thought of let me start also in the education activities every weekend or maybe once in a month.
So nice to see you.
If you want some lectures to be given to the college students or your university in engineering, you can invite me. No problem.
Yes, Sanjay.
Okay. So I
Nice to
normally
see you,
do
Miss
give
Preeti. Nice to
lectures
see you.
on Kolkata-based
Same here,
universities.
sir.
Thanks.
Same here, sir. Same here.
Okay. Okay.
Amy,
Thank you.
bye-bye.
Thank
Bye.
you. Bye.
Bye.
Bye. Bye. Bye. Bye.
Have
Thank
a
you.
good weekend. Bye. Bye.
Yeah. Okay. Thank you very much.
Oh,
Thanks.
thank you.
Thanks,
you.
Jennifer.
Bye-bye.
Thanks. Professor Sardar. Thank you.
Thank you. Thank you.
Bye. Something we learned recently